Time now to solve some exam questions regarding motion with varying acceleration. The first exam question is from a spring 2015 exam. That's paper 43, question 7. It says, a particle P moves on a straight line. It starts at a point O on the line and returns to O 100 seconds later. The velocity of P is v meters per second at time t seconds after leaving O, where v equals, and you have here an expression of v in terms of t. Show that P is instantaneously at rest when t equals 0, 50, and 100 seconds. That is the first sub-question. Out of this, you would have a total of 3, totaling 13 points for this question 7. So this one is very simple. You want to show that P is instantaneously at rest on these particular points, so equal this to 0. At rest means speed equals 0, obviously. So, where am I? I'm on the wrong place. Okay, this is a little bit slow, but now I'm on the correct place. So I want to equal this expression to 0 to solve it for the moments when the object was stopped. So I just factorize the t. I then solve it. Each one of the factors equals 0. This quadratic can be factorized itself into this one. So here you have the 3 times as supposed. Now, the next question is, find the values of v at the times for which the acceleration of p is 0 and sketch the velocity time graph for p's motion from 0 to 100 seconds. 7 points for this. Okay, so we already know that at these times the speed is 0. This is going to be important to sketch the velocity time graph. We need to get the actual velocity when the acceleration is 0. To get the values or the times when the acceleration is 0, we first need to get an expression for the acceleration. If we have an expression for the velocity to start with, we differentiate that, equal it to 0, and by solving it, we'll find the times at which the acceleration was 0, okay? If we differentiate the cubic, we'll have a quadratic. In this case, I use the method of completing the square to solve it. You can use whichever method you want. And I get these 2 times, and these are the times when the acceleration is 0. To actually get the values of the velocity at these times, now just substitute them on the expression for the velocity. That's what I did here. And I have the actual velocity when the acceleration is 0. Okay? So now I have everything. I have here 0, 50, and 100 as the times when the velocity was 0. I have the maximum velocity when the acceleration is 0, 4.81. I have the minimum velocity when the acceleration is 0, minus 4.81. I plot these points. I know that this is going to be the maximum velocity it's going to get. All right. Now, the acceleration is going to be negative from this moment onwards. So there you have it. After plotting these points, it will be easy for you to just sketch the graph. Last question. Find the greatest distance of P from O for this period of time, from 0 to 100 seconds. The greatest distance from O. What is happening over here after analyzing this graph? The speed is increasing. Okay, it starts from here. Let's say that this is the origin O. Its speed is increasing. It gets to a maximum speed and then starts decreasing until it's 0, and then starts increasing in the opposite direction. It gets a maximum, and then the speed is going to be 0 again. Okay, when is going to happen the maximum displacement for O? That's on this point over here. This point over here happened at 50 seconds, right? Again, the speed increased, got to a maximum, decreased, and then eventually was 0. From this moment onwards, the particle is going to start moving back to O. All right, so the time of interest for this question is 50 seconds. All right, we want the distance. We have an expression for the velocity in terms of time, so we integrate this to get an expression for the displacement. And the limits of integration are going to be 0, obviously, and 50 for the reason I just told you. All right? Then it's just a matter of knowing how to integrate this expression. Here is the primitive between 0 and 50. I substitute 50. No need to bother to substitute 0 because all of these are going to be 0. And there you have the result, 156 meters. All right? 13 points. Not that difficult. This is from a June 2007 paper 4. It's question 6. A particle P starts from rest at the point A and travels in a straight line, coming to rest again after 10 seconds. The velocity time graph for P consists of two straight line segments, like you can see in this diagram. Then you have a particle Q that starts from rest at A as well, at the same time as P, and travels along the same straight line as P. The velocity of Q is given by, and here you have an expression of V in terms of t, for 0 to 10 seconds, same as that. The displacements from A of P and Q are the same when t equals 10 seconds. After 10 seconds, whatever the displacement of P is the same as the displacement of Q. Knowing this, show that the greatest velocity of P during the motion is 10 meters per second. Okay, so I just summarized everything over here for P and for Q. All right. I know that this is what I need to prove. Okay, sorry. I need to prove that the maximum velocity of P is 10 meters per second. We know that when t equals 10 meters per second, the displacement of P is given by the area of this triangle, which is the base, 10, times the maximum velocity, that's the thing that we want, divided by 2. Okay, so basically it's 5 times the maximum velocity that we need to calculate. But we know that this displacement is the same as for Q at the end of 10 seconds, right? So how do we get the displacement of Q? We have an expression for V in terms of t, so you integrate this to get an expression for the displacement. I could have used already here the limits of integration, but I decided to put a primitive first. I don't know why back then. Might as well just put here the limits of integration and I will have this result straight away. But anyway, I just integrated it. I used the fact that at the origin the displacement is 0 to get rid of this arbitrary constant, that's 0. Okay, so here is the primitive. Now substitute by 10 and 50 meters is the answer. So if x at P and x of Q is the same when they are both 10 seconds after moving, then 5 Vmax equals 50, which means that the Vmax equals 10 meters per second. All right? Find the value of t in the interval 0 to 5 seconds for which the acceleration of Q is the same as the acceleration of P. First, we need to get the acceleration of P. All right? It's just the gradient of that line. It's 2 meters per second squared. The acceleration of Q is given by the derivative of that, which is just 3 minus 0.6t, equal this to that, and you get the value of t. As simple as that. Last one. November 2009, paper 41. The question is the last one, is question 7, a total of 12 points as well. A particle P starts from rest at the point A at time t equals 0, where t is in seconds, and moves in a straight line with constant acceleration a meters per second square for 10 seconds. For the time interval between 10 and 20 seconds, P continues to move along the line with velocity v meters per second, where v is given by that mathematical expression. Find first the speed of P when t equals 10 seconds and the value of A. Okay, you have two segments for this motion. Every time you have that, you will know that on the point of transition from one segment to the other, the speed must be the same regardless of the method that you calculate. That is, if you use the mechanics, if you use the kinematics of this part, and if you use the kinematics of this part, the value for the speed should be the same, right? So if you want the acceleration over here, you know that The initial speed is 0, but you don't know yet the final speed over there. Okay? And you also don't know, you know the time, it's 10 seconds, of course. You don't know the final velocity. You need to use information about this second part to get this velocity, all right? And if you use the information of the second part, this is the thing that you'll look at, okay? When t equals 10 seconds, just substitute it over here, and you have a speed of 6 meters per second. You calculated using this one, but this speed is the same as at the end of this segment. It could not just suddenly jump from one value to 6, right? So it was 6 at the end of this journey over here, this segment over here. So you now know the final speed. So the acceleration is 6 minus 0 divided by 10 is 0.6 meters per second squared. Find the value of t for which the acceleration of p is minus a meters per second squared. So now you know that this is minus 0.6 meters per second squared. You need to know the value of t for which the acceleration was the negative of that. All right? What is the expression for the acceleration? Is the derivative of that. So let's just differentiate that. And this is just going to be minus 2 times 800, which is minus 1,600, divided by t to the power minus 2 minus 1, which is t to the power minus 3, or basically just that. We know the value of the acceleration is minus 0.6, so equal this to that, solve it, and you have the time. How many points for this? 4. Yeah, okay. Simple enough. Then the displacement of p from A when t equals 20 seconds. Again, how do you get the displacement? For this segment over here is going to be the integral of this. And for this segment over here is going to be the, you can use kinematics, right? After 20 seconds, you have to take care of the situation that you have, which involves two different segments. So for the first one, you just use the SUVET formulas that you learned before because you have a constant acceleration, all right? So u equals 0, so you basically just have that part, 1/2 of a, 0.6 t squared, so 30 meters over here. And then for this part over here, you just do the integral starting at 10 seconds up until 20 seconds of the expression for the velocity. Now, just calculate the primitive, substitute by the values 20 and 10. Don't mess up with this minus, it's a common source of mistakes. This minus is minusing the whole expression over there, all right? And you have the result 20, okay? So 10 meters over here, 20 meters over here, so, I'm sorry, 30 meters over here, 20 meters over here, so the total distance is 50 meters.